And hello, part two of 6.3. We are going to be once again looking at logs and exponentials. Sorry, get myself in order here. And we're going to find inverses of each other. And this is going to be a process very, very similar to when we were together earlier and we found inverses. And remember, the key to finding inverses is to switch x and y back and forth. And that is a very, very important step. And then from there, you'll be able to solve. Remember, when we did switch x and y back and forth, we're trying to ultimately get y by itself. Okay. And these aren't my notes, so I'm not sure necessarily specifically what go in these blanks. You can look back at the notes that will be posted later to what specifically go in these blanks, but we'll do a couple examples here to hopefully at least make sure that you understand the process. Okay, so what we are going to do first here is change the f of x to a y. And then your first step, remember, is to switch x and y back and forth, switch x and y back and forth. So I have x is equal to log of 4y. Now, I mentioned in the previous video that logs will always have to have a base. And in this case, the base is not written. So since the base is not written, we are going to assume that there's a 10 there. There is a 10 there. So I'm going to rewrite this in exponential form. All right, that's kind of what they're getting at up here, exponentiate the base. So I'm going to rewrite this in exponential form. All right, so that's why this process that we talked about last video was so important. You take your base of the log, which is 10, to the power of what's over here, which is x, equals what's next to, which is 4y. All right, so base to the power of what's over here is equal to 4y. Now, if you have 4 times y, to undo that, you have y is equal to 10 to the x all over 4. All right, so that is what the inverse function is. F inverse of x is 10 to the x over 4. And if you want, I'm not going to do this right now, but what would maybe be a good idea is to see what these things look like on your graphing calculator. Okay, actually, I just changed my mind. I will show you. All right, so I started with y equals log of 4x, and then I had y equals 10 to the x over 4. Okay. So I'm hoping that these are inverses of each other because that's what I found to be true. And how I can graphically verify this is, if you remember from when we did inverses, they should be symmetric over the line y is equal to x. If I put that line actually in here as well, all right, it looks pretty symmetric over that line. And if I take a look at my table as well, I can compare and see if I have any values that where x and y get switched. So if I come up here, do I have any of those? Well, I had one way down there, but I think you can see from the graph that these are inverses of each other. They are a reflection over that line y is equal to x. Okay, so this is always a good way to graphically verify whether or not you do have inverses. Okay, so let's take a look at this one. Once again, let's switch x and y back and forth to start. Okay. Rewrite this in exponential form. That's step 2. So you take your base, which is 2, to the power of what's over here, which is x, equals what's next to, which is 5y. And to get rid of times 5, you will divide each side by 5. So the inverse function, f inverse of x, would be 2x over 5. Okay? So kind of combining what we've done earlier with earlier this unit with what we've done even earlier than that with finding inverses. Okay? So they're going to get a little bit more complex here, so let's just do a few more of these. First off, switch x and y back and forth. And remember, natural log is the same thing as log with the base of e. So if you're still kind of unsure what a natural log is and you want to rewrite it as log base e for now, that's fine. It kind of gets you the idea, because then that might be more helpful when you rewrite it in exponential form. You take the base. Well, the base, maybe it's hard to see when you have ln. So the base here is e to the power of what's over here, which is x, equals what's next to, which is y plus 3. All right, and then to get rid of a plus 3, you subtract 3. And once again, if you put this into your calculator, natural log of x plus 3, and then e to the x minus 3, you will see that they are inverses of each other. They do voice crack. They do have that y equals x line of reflection. Okay, so let's take a look at number 4 here. Log base 5 of x minus 4 plus 7. First step, finding inverses. Switch x and y back and forth. So I switch x and y back and forth. And now I'm actually going to go ahead and solve for y. So before I start switching everything around, I kind of like it when it's just the log of something on one side. This plus 7 is kind of cramping my style, so I'm actually going to subtract 7 from each side first. So then what you have on the left side is x minus 7. This plus 7 minus 7 cancel out. So I've subtracted 7 from each side. Now I kind of have my log with something just kind of isolated. So I am going to rewrite this. I'm going to just go over here now. I take my base, which is 5, to the power of what's over here, which is all of x minus 7, is equal to y minus 4. Okay, so this whole thing is the exponent. Whatever this thing is, that will get raised to the power 5 to the power of x minus 7 equals what's next to. Now I have a y minus 4. To get rid of a minus 4, I will add 4 to each side. So then my inverse function here is 5 to the x minus 7 and then plus 4. And that looks pretty inversey, right? You have exponents, which is the inverse of log. Here you have a minus 4. Here you have a plus 4. Here you have a plus 7 and a minus 7. So there's a lot of inversey stuff going on, which is another kind of good indicator that you did things correctly. All right. So as long as you remember to switch x and y back and forth, and then when you have a log, rewrite it in exponential form, and then do a little bit more algebra, and you should be all set. So you can check. You can try these out and then check the note key posted to see if you got them correct. All right. So take some time to do that now. Pause this video because I'm going to keep going. The second part of this is we're going to find the inverse of an exponential. So notice what we did earlier. These were all logs. So we were finding the inverse of a log. All of these had logs. We ended with exponents. Exponent, 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 exponent. Okay. Now we're going to start with an exponent and we're going to end with a log because, once again, those are inverses of each other. And the process will be the same. Switch x and y back and forth. Ultimately get y by itself. Okay. And the process here is a little bit different in the sense that you're going to take the log of both sides. If you're going to take the log of one side, you can't just take the log of one side. You have to take the log of both sides. It's just algebra techniques. Okay, and I'll show you what happens. I'll tell you my little weird way of how I help kids remember this. Y is equal to 6 to the power of something. Switch x and y back and forth. So you have x is equal to 6 to the power of y. Right. Now, a lot of people just think this is divide by 6 and you're done. But that is not correct. Okay, this is not 6 times y. This is 6 to the power of y. So we need somehow, some way, for this exponent to no longer be an exponent. All right, we need to de-exponentialize it. So the inverse of exponential is log. So if you're going to take the log of this side, you have to also take the log of this side. Okay, so you take the log of each side. So on the left, you just still have log of x. Now, here's my weird way of remembering how this works. Okay, the mathematical way is that the log undoes the exponent, right? Just like multiplication undoes division and subtraction undoes addition. But here's my weird way of how I can relate to teenagers. Okay, so as a teenager, here you are. Up here, you're hanging out, you're upstairs, you're home, you're upstairs, you're hanging out in your room, all right, doing some TikToks or whatever, keeping your snap streaks alive, probably not doing math. Maybe, hopefully you're doing math. Some of you might be. Okay, but you're upstairs, away from your family because talking to your family or parents or grandparents or brothers and sisters is so woefully uncool. So here you are, you're upstairs. And if you have if guests come over, you even further want to seclude yourself because you don't want to mingle and socialize with people that are out of your network. So you want to stay upstairs. Except when the logs come over, you want to come downstairs for that because you're having so much fun doing logs right now that when the logs come over, here comes the logs. You need to come downstairs. So you waddle yourself downstairs. Okay? So here you are. You were downstairs, or you were upstairs, way up here. Woohoo! Now you came down on the main level because you know what? The logs are here. And the logs are awesome. So you need to hang out with the logs. And you hang out with the logs until they leave. When are they going to leave? Well, they leave right now. This is to get rid of times log of 6. You will divide each side by log of 6. So your final answer here is y equals log of x divided by log of 6. And you can rewrite this in exponential form, or excuse me, inverse function notation form. All right, but the biggest thing that I want to stress is the process here. The log undoes the exponent, so then the exponent comes down. Or if you're more relatable to the teenager hanging out upstairs, and then you're upstairs and the logs come over and you want to come downstairs, then maybe that's more relatable for you. So let's take a look at number 2. Let's switch x and y back and forth. This minus 10 is not up here, so I'm actually going to get rid of that first. So since you're subtracting 10, to undo subtract 10, I will add 10 to each side. And here you are, you're upstairs, you're hanging out, you're trying to get y by itself, so you know like y is what you need to work with, y is an exponent. So you think to yourself as a teenager, you're like, ooh, here I am hanging out upstairs. Me and my best friend 4, we're really, really close, maybe too close. All right, there is some room here for the Holy Spirit. We're hanging out upstairs, don't want to be bothered, but who's knocking on the door? It's the logs. The logs are coming over. And so, since the logs are that cool, you're coming downstairs. And you're bringing the 4 with you. You guys are still really close, holding your hands, coming down the stairs, probably sprinting down the stairs because logs are so fun. So I took the log of this side, I took the log of that side, but because I took the log of this side, it de-exponentializes this, and the exponent comes down. All right, so now to get rid of times log of 2, I will divide each side by log of 2. Sorry, that's fine. And now we still have 4 times y. To undo times 4, we will divide by 4. Dividing by 4 is the same thing as multiplying by 1/4. So I'm dividing by 4. And there is my inverse. Should have given you more room here. I need more room. You probably need more room as well. Okay, so let's do just a couple more examples. Once again, I think this one tends to be a little bit more challenging, so we'll do a couple more examples together. Hopefully, it'll start to click here soon. First step always is to switch x and y back and forth. So I did that. Here you are upstairs. You're losing 7 friends on Snapchat because you've broken your streaks or something. I don't know. But you're upstairs, don't want to be bothered, but there's a knock at the door. Who is it? The logs are coming over. Why are the logs coming over? Because you're upstairs and your family wants you to join them on the main level. So they call up the logs. Or, mathematically speaking, logs, exponents, inverses of each other. So if you have exponents and you want to undo exponents, you need logs. So the left side remains log of x. The logs are over. You and your minus 7 friends come down and multiply with this log of 3. Now to solve for y, I will undo multiplication with division. So divide each side by log of 3. And now lastly, to get rid of this minus 7, we will add 7. And there's your inverse function. Excellent. Excellent. Excellent, excellent. All right, we'll do this last one right here, and then you can check your answers for these. So, last one, f of x is equal to e to the 2x. So I'm actually going to, I'll just do that one right here. I'll rewrite it. Since I have clearly not used my space well. Okay, so this is the last one, number 4. Okay. Switch x and y back and forth. So here you're upstairs, you're trying to solve for y. So since you're trying to solve for y, you need y to de-exponentialize itself. All right. Now all of these, we've just taken logs. Now this time, this is where things get really exciting. Because the base is an e, and we want to undo that base, we won't take the log of each side. We're actually going to take the natural log of each side. All right. So these kind of just like cancel each other out, and you're just left with 2y. Right? The logs came over. So since the logs came over, you came downstairs to the main level. And now, since those cancel out and you want to get y by itself, you will divide each side by 2. So y is equal to the natural log of x divided by 2. And once again, you can check your answers on each of those on the notes that will be posted, the note keys that will be posted. So, recap, we talked about both how to find an inverse of logs and how to find the inverse of an exponential. Similar processes, in fact, that you have to switch x and y back and forth each time. But whether you start with a log or start with an exponent, that process gets a little bit different. So hopefully going through those proves helpful. Once again, good work. Have a wonderful day. Much love.